We all know that the chemical formula for water is H2O, and we know that this means each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. But what most people don't know is that this means that the water molecule has some very interesting properties. Let's take a look. How exactly do the 2 hydrogen atoms and the oxygen atom combine? Is it like this? After all, that's H2O. Or is it like this? Actually, it's neither of those. Because of the way the electrons move around the oxygen atom, the hydrogen atoms actually line up like this. Because of the nature of these atoms and the electrons that flow around them, this means that this end of every water molecule ends up being slightly negatively charged, whereas this end ends up being slightly positively charged. This means that each molecule is in itself a dipole, meaning that it has both a positive and a negative end. So when we think of water on the molecular level, we should think of an image something like this. And this explains why water is so very good at dissolving salts. The negative and positive ends of each water molecule love to attach themselves to the charged ions that are found in other molecules.
And the dipole nature of H2O also explains another interesting thing about water. It explains why ice floats. And to understand that, we need to look at what happens when water molecules transition from one state to another.
When thinking about water in a gaseous state, as steam, we should envision something like this. Individual water molecules spread out and moving rapidly relative to one another. But as the temperature is gradually cooled and comes closer and closer to 100 degrees Celsius, watch what happens. The molecules become less and less energetic, and the distance between them gradually lessens. Eventually, they begin to adhere to each other very loosely in a way that leaves them clumped together as water droplets in the liquid state. That is how we end up with dewdrops. And, of course, raindrops. In our animation model, H2O inside these liquid droplets now looks something like this. The H2O molecules are far less energetic than they were as steam, and they are very much closer together. This is liquid water. This is the stuff of which we are made. And now, watch what happens as we lower the temperature even further. The molecules become even less energetic and even closer together. This is not surprising. That is what happens to the molecules of virtually every substance when it's cooled. But when the temperature gets really close to the freezing point, 0 degrees Celsius, H2O does something unusual. Because each water molecule is a dipole, strong electron bonds form as the positive ends of each water molecule attach themselves to the negative ends of others. As a result, the water molecules align themselves into a crystal lattice like this. And when they do this, they actually spread out a bit. That is, the average distance among water molecules in the crystal state is greater than the average distance when H2O is a liquid. This is why water expands when it freezes. This is why solid H2O, ice, floats on top of liquid H2O.
We take it for granted that ice cubes float when placed in liquid water. But when we stop to think about it, we realize that H2O is quite unique in this way.